Okay, good morning students. So far we have discussed reflection of light, then the laws of reflection, then the various types of mirrors, that is concave and convex mirrors. What are the various definitions or what are the parameters involved in concave and convex mirrors? Where exactly is the position of the object and where exactly is the position of the image? What are the different cases? And we have also solved the numericals. Now it's time to proceed with the next half of the chapter, that is refraction. Okay, we have learned only reflection. Now it is refraction. Okay, before going to what exactly is the refraction, I want to demonstrate few daily life observations pertaining to the refraction. What exactly it is, just carefully observe. Now I have taken a glass beaker which is filled with 3/4 of the water. ಒಂದು ಗಾಜಿನ ಲೋಟ, ಲೋಟದಲ್ಲಿ ಮುಕ್ಕಾಲು ಭಾಗ ನೀರು ಹಾಕಿದ್ದೀನಿ. Now carefully observe. If I insert a stick, if I insert the stick in such a way that half of the stick is above the surface of the water and half of the stick is immersed below the surface of the water, carefully observe the stick, and you can just see here. Now I have immersed like this. Can you see here? I hold like this. So what is the conclusion that you can make, or what is the observation that you are making here, or what physics that we can obtain from this particular demonstration? The stick which is above the surface of the water, which means in air, is actually what? It is straight. There is no damage, nothing. But the stick which is immersed in the water appears to be bent. ಈ ಒಂದು ಕಡ್ಡಿಯ ಮೇಲ್ಭಾಗ ಏನಿದೆ ಗಾಳಿಯಲ್ಲಿರೋದು ಅದು ಸ್ಟ್ರೈಟ್ ಆಗಿದೆ, ಏನು ತೊಂದರೆ ಆಗಿಲ್ಲ, ಅದಕ್ಕೆ ಅದು ಹಾಗೆ ಇದೆ. ಆದ್ರೆ ನೀರಿನಲ್ಲಿ ಮುಳುಗಿರುವಂತಹ ಭಾಗ, ಆ ಒಂದು ಕಡ್ಡಿಯ ಭಾಗ ಏನಿದೆ ಅದು ಬೆಂಡ್ ಆದಂತೆ ಕಾಣುತ್ತೆ. ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ರಿಫ್ರಾಕ್ಷನ್. ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ ಅಂತಂದ್ರೆ ಬೆಳಕು, ದ ಲೈಟ್ when traveling in one medium enters the other medium, it undergoes the change in path. ಅದರ ದಿಕ್ಕನ್ನ ಬದಲಿಸುತ್ತೆ. ಒಂದು ಮಾಧ್ಯಮದಿಂದ ಇನ್ನೊಂದು ಮಾಧ್ಯಮಕ್ಕೆ ಬೆಳಕು ಹೋದಾಗ ತನ್ನ ದಿಕ್ಕನ್ನ, ತನ್ನ ಹಾದಿಯನ್ನ ಬದಲಿಸುವಿಕೆ ಏನಿದೆ, the direction in its change of path is called as refraction. This is one example. One more I will show you. Now see here, this is the lemon. ಇದನ್ನ ನಿಂಬೆ ಹಣ್ಣು ಅಂತ ಕರೀತೀವಿ. This is lemon. Now again I have taken a glass beaker filled 3/4 of water. Now see the symmetry of the lemon, the size of the lemon. You can see the size of the lemon. Just observe when I put this lemon within the water. Now see here. So what is the observation that we are making here? The lemon appears to be larger in size, right? ನಿಂಬೆ ಹಣ್ಣಿನ ಗಾತ್ರ ದೊಡ್ಡದಾಗಿರೋ ತರ ಕಾಣುತ್ತೆ, ಎಕ್ಸಾಕ್ಟ್ ಆಗಿರಲ್ಲ, ಅದು ಭಾಸವಾಗುತ್ತೆ. ನೀರಿನಲ್ಲಿ ನಿಂಬೆ ಹಣ್ಣು ಮುಳುಗಿರುವುದರಿಂದ ಏನಾಗುತ್ತೆ, the size of the lemon appears to be large. Not only that, if you hold the same water like this down, now if you are observing from here obliquely, if you are observing, not only do you see the lemon being bulged or being large, when you are holding like this, and if you are seeing from obliquely, the lemon appears to be raised. ನಿಂಬೆ ಹಣ್ಣು ತಳಭಾಗದಿಂದ ಮೇಲ್ಭಾಗಕ್ಕೆ ಬಂದಿರೋ ತರ ಕಾಣುತ್ತೆ. It appears to be raised, not exactly, it is actually settled down at the bottom. But due to this refraction, the lemon not only appears large, it appears to be raised above at some distance. I'll show one more example. Now students, again I have the glass beaker filled with water. Now I have a coin, a 5 rupees coin I have. Now just observe here. I will put this coin. You can see the size of the coin. Okay. Now if I am inserting here, so you can see here. The coin appears to be bulged or large. Same like lemon. Not only that, if you are holding like this, when I am observing, the coin appears to be raised above. This illustrates that there is refraction. Now coming to what exactly is the refraction. Now you can see here. Refraction is the phenomenon of change in the path of light when it is going from one medium to another medium. When the light travels from one medium to another medium. So means what? Medium means what? Medium means madhyama, where the light has to travel, right? Optical medium. Now earlier in reflection, there was only one medium for the law of reflection, which means light is coming, then there is a normal, it is making some angle of incidence, then the light is reflected back to the same medium, right? Angle of incidence is equal to angle of reflection. But here it is not so. Here light is coming in one medium and it is entering into another medium. Say for example, I'll give air is the medium in which the light is emerging. Means the source is located in the air, the light source. So when the ray of light is coming in the air and suddenly if you get water, the light has to enter the water. It will enter the water. Why? Because water is also an optical medium. So what happens? The light path, the light ray will change its path. Okay, adara dariyanna badalisute, will deviate, will bend. That is called as refraction. The phenomenon of change in the path of the light going from one medium to another medium. The light bends from its original path on entering another medium. As I told you, it will bend its original path. So what are the examples? The letters on the page appears to be raised when viewed through a thick glass slab. You hold the book, you take a rectangular glass slab, thickness should be more, you hold it, okay, place the glass slab above the book. Now, the letters which are written on the page of the book appears to be bulged and raised when you are seeing through the glass slab. So that is also refraction. Now I have demonstrated the experiments, right? The coin in a glass tumbler filled with water appears to be raised. A lemon kept in the glass filled with water, when viewed from both the sides, appears to be bigger than actual size. A pencil partially immersed in the water appears to be bent in the interface of air and water. What do you mean by interface of air and water? Now you can see here, this is the interface. Above is the air, that is medium 1. Below is the water, this is the boundary. Just how we have the boundary for India and Pakistan, right? That similar. This above which you have what? Air. That is first medium. Below which you are having water. And this is the boundary. That is called as interface. Okay. So these are the few examples to illustrate refraction. Thank you. Okay students, moving to the refraction. Again we can show in the ray diagram how refraction happens. We have understood the concept of refraction from the various experiments. Okay, what do you mean by refraction? The change in the path of the light when it travels from one medium to another medium, or when it enters from one medium to another medium is called as refraction. Now you can see here, this is the ray diagram. Okay, now N, O, N dash is the normal. You know what is the normal, right? A normal is a line which is drawn perpendicular to the plane of or interface of separation, or the boundary that separates first medium and second medium, that is XOY. XOY is called boundary of separation between medium 1 and medium 2, or it is also called as interface. To this interface, NO N dash is perpendicular light. It is making an angle of 90 degrees. So that's why NO N dash is normal. Now see here, this is medium 1, means air. From air now light will come first. Now the ray of light is entering the first medium, medium 1, that is air, and it is making an angle of incidence. That is, incident ray will make an angle of incidence I at the point of incidence. What is the point of incidence? O. So it is making an angle I with the normal. Now this is not reflection, this is refraction. That obviously this ray has to enter the next medium, that is what? Water. Now this is water. Now what will happen? What will happen? The ray will not travel straight. It will not travel straight, right? So what it will do? It will shift. It will deviate. Now you can see here it has bent. Okay, it has bent. See, this is the ray of light. If there was no water, means it would have traveled like this straight. Since there is a medium water, when it enters the water medium, that is the second medium, there is change in the path of light. So that ray will become refracted ray. So refracted ray is present in which medium? Second medium. Incident ray is present in which medium? First medium. Now you can see the refracted ray which is bent, or there is a change in the travel, right? There is a change in the path of the incident ray. Now that change in the path of the incident ray is called refracted ray, which is observed in the second medium, water. So this refracted ray is also making an angle with the normal, that is called as angle of refraction, R. R is called as angle of refraction, okay? And this ray is called as OB is refracted ray. OA or AO is called as incident ray. So this is the ray diagram to illustrate the refraction. The same thing they have written here. NO N dash is the normal, O is the point of incidence, AO is the incident ray, OB is the refracted ray, XOY is the interface or boundary of separation, angle I is the angle of incidence, angle R is the angle of refraction. Now you can see here, angle of incidence is not equal to angle of refraction. It should not be equal also. Why? Because in reflection, remember second law of reflection, angle of incidence is equal to angle of reflection, but here it is not so. See here, incident ray is bigger angle, it is large angle. Since the refracted ray is bending where? The refracted ray is bending towards the normal, right? So this angle, this is bigger angle, this is smaller angle. So angle of incidence is greater than angle of refraction. Angle of incidence is greater than angle of refraction when the light is traveling from first medium to second medium. Take for example first medium as air, second medium as water. Okay. So angle of incidence is greater than angle of refraction, then the refracted ray bends towards the normal, means it is bending towards the normal, means angle decreases, angle of refraction decreases in going from medium 1 to medium 2. Thank you. Okay students, we have learned what is the refraction process through the ray diagram. So you require optical medium, the two medium, first medium and second medium. That first medium in which you have incident ray, the second medium in which you have refracted ray. Now that medium is having certain parameters because of which there is refraction. Now what is that called as? That is called as refractive index. It is just a constant number, but without refractive index there is no refraction. So whether it is medium 1 or medium 2, whether it is air or water or glass, whichever medium, it should have its own refractive index. Okay. Now we can understand the refractive index, or we can get into the concept of refractive index in various dimensions. Okay. The first thing is to understand the refractive index in terms of velocities of light. Okay, in terms of velocity of light, or speed of light. Okay. That speed of light in which medium? That is in first medium air, the speed of light in water, the speed of light in glass. Okay, so that will give you what? The exact dimensions for the refractive index. Means refractive index in terms of speed of light. Okay. Now, before going to what exactly is the refractive index, you have to understand certain fundamentals here. First is, you know that the speed of light in air or vacuum or free space, all three together, that is air or vacuum or free space, is equal to 3 into 10 to the power of 8 meters per second. You know what is the number of 3 into 10 to the power of 8, which means what? 3 ಪಕ್ಕ 8 ಸೊನ್ನೆ ಹಾಕೋದು ಅಂದ್ರೆ ಎಷ್ಟಾಯ್ತು? 3 ಪಕ್ಕ 7 ಸೊನ್ನೆ ಹಾಕಿದ್ರೆ 3 ಕೋಟಿ ಆಯ್ತು. ಅದ್ರ ಪಕ್ಕ ಇನ್ನೂ 1 ಸೊನ್ನೆ 30 ಕೋಟಿ. ಅಂದ್ರೆ 1 ಸೆಕೆಂಡ್ಗೆ ಗಾಳಿಯಲ್ಲಿ ಬೆಳಕು 30 ಕೋಟಿ ಮೀಟರ್ ಕವರ್ ಮಾಡುತ್ತೆ. ಜಸ್ಟ್ ಯು ಕೆನಾಟ್ ಇವನ್ ಇಮ್ಯಾಜಿನ್ ಆಲ್ಸೋ. ಓಕೆ, ಸೊ ದಟ್ ಈಸ್ ದ ಸ್ಪೀಡ್ ಆಫ್ ಲೈಟ್ ಇನ್ ವಿಚ್ that is air or vacuum or in free space. So that is the thing that you have to know. Next, I have been telling you what is the light requires some optical medium or medium to travel. That is called as optical medium. Now, what is this optical medium? Optical medium is a transparent medium in which the light will travel. That's it. Air is an optical medium, water is an optical medium, glass is an optical medium. Okay, an optical medium is the transparent substance in which the light travels. Next, now you have, for our example, I have taken air, water and glass to be different optical medium. There are many optical mediums. Even you have kerosene, even you have turpentine. Okay, so there are many optical mediums. So for our convenience, in order to know the concept, okay, we have taken air, water and glass. Okay, now different optical mediums have different optical densities. Now see here students, different optical densities. The general density what we speak, ಸಾಂದ್ರತೆ ಅಂತ ಕರಿತೀವಿ ಕನ್ನಡದಲ್ಲಿ, that is density of water, density of air, density of glass or density of any substance in general, that is different. Optical density is different. Optical density is related to only the light when it is entering into that medium. That becomes optical density. So don't confuse the general term of density to the optical densities. Okay. Now, different optical medium will have different optical densities. So that is the reason why the speed of the light keeps varying or keeps changing. That's why the speed of the light in air is having some value 3 into 10 power 8 meter per second. This is not the same when the light, when it enters to water, when it enters to glass. So it varies. Okay. Now, as I have told you that for the refraction there has to be two mediums. That is the medium, the first medium from where the light originates or the light ray travel, and the second medium in which the light ray will undergo the refraction or there is bending. Now, those two mediums in physics we have given the name called as rarer medium and denser medium. Rarer medium and denser medium. So what exactly is rarer medium? The medium in which the speed of light is more. The first medium where the light is actually coming. So if I can give the example, take air and water. Air is the medium in which the light ray is coming first. That first medium is called rarer medium. In air, speed of light is more. You can see here the value. That's why it is called as rarer medium. Now, coming to denser medium, the medium in which the speed of light is less. Now, when the ray of light coming from the rarer medium, that is air, when it enters into the medium 2, its velocity decreases. That's why that medium is called as a denser medium, where the refraction process will happen. In that medium, the speed of the light decreases. Okay, so the medium in which the speed of the light is less, that is called as denser medium. We are speaking the optical medium in terms of velocity or the speed of light. Now you can see here the speed of the light in the rarer medium. We represent speed. Speed of light in rarer medium is greater than speed of light in the denser medium. Or the other way around, speed of the light in denser medium is less than the speed of the light in rarer medium. Now I have given certain examples here. Now these are all the numbers. Okay, these are the accurate numbers. Now, speed of light in air 3 into 10 power 8 meter per second. Now compare speed of light in water 2.25 into 10 power 8 meter per second. So its value decreased. Speed of light in glass 2 into 10 power 8 meter per second. Still its value decreased. Now, why are you seeing this difference in the density, difference in the speed of light? Because of the optical density, variation in the optical density. Now you can only say that which is the rarer medium and which is the denser medium. Now if I can make a comparison, see here, air and water. See here, air and water. See the speed. Now which is rarer? Air is the rarer medium, water is the denser medium. That is medium 1, medium 2. Okay. Now second comparison, we can make air and glass. Now see the speed of the light in air, 3 into 10 power 8 meters per second. Speed of light in glass, 2 into 10 power 8 meters per second. Now which is rarer, which is denser? Air is the rarer medium, glass is the denser medium. Now coming to the third case. Now see here I have made the comparison with these two, water and glass. See the speed of light in water, 2.25 into 10 power 8 meter per second. Speed of light in glass, 2 into 10 power 8 meter per second. Which is more? Speed of light in water is more than the speed of light in glass. That's why water is the rarer medium, glass is the denser medium. Hope you have understood how to classify the rarer and denser medium. Thank you. Okay students, now we have understood that the refraction happens in the second medium. Okay, which means we need to have two mediums, medium 1 and medium 2. And in that medium, very important thing is refractive index. Now what is the definition of the refractive index? Refractive index is also called absolute refractive index. Now refractive index or absolute refractive index denoted by small n is defined as, it is defined in the ratio of speed of light in the vacuum. Vacuum means in the air also the speed of light remains constant, 3 into 10 power 8 meter per second. So it is defined as the ratio of speed of light in vacuum to the speed of light in any medium or in general medium. I repeat, refractive index is defined as the ratio of speed of light in vacuum to the speed of light in the medium. Here medium means any medium. You are just making a comparison to the speed of light in vacuum. Why? Because we are able to see only the speed of light when we are seeing the light in the speed of light in air. So what happens to its speed when it goes to water and all? By comparing to the air we will find out. Okay, the refractive index. So n is equal to C by V. Here C means speed of light in vacuum, V means speed of light in any medium. So we have got the definition for refractive index. What is the definition for refractive index? It is defined as the ratio of speed of light in the vacuum to the speed of light in the medium. Now let us see the example. We know the speed of light in vacuum, 3 into 10 power 8. But what we don't know the speed of light, we have to find the refractive index of glass. We have to find the refractive index of glass. Apply this formula. C remains constant. I have told you that is speed of light in air divided by V of G or Vg I have taken. Why? Because what is the speed of light in glass? That speed of light in glass is 2 into 10 power 8. Whereas speed of light in the air is 3 into 10 power 8. We are just comparing, okay? Taking the ratio, 10 power 8, 10 power 8 cancels, you will get 3 by 2. You will get the refractive index of glass is equal to 1.5. Refractive index of glass is 1.5. Okay? Now you can ask, what is the refractive index of air? We will come to that later, okay? Now we have find out the refractive index of glass using this formula, where this numerator C, 3 into 10 power 8, is constant, that is 3 into 10 power 8. In the denominator, speed of light in glass is 2 into 10 power 8, so that you will get the refractive index of glass. Next, we have to find out the refractive index of water. Use the same formula, N is equal to C by V. Therefore, NW, refractive index of water, is equal to C by VW. C by VW. Again, just before how we have taken same thing for C, 3 into 10 power 8 divided by, now see the speed of light in water, 2.25. Make a comparison to this. Speed of light in glass is less as compared to the speed of light in water. 2.25 into 10 power 8, it gets cancelled. That's why refractive index of water is 1.33. 4 divided by 3 is 1.33, which means refractive index of water is less than refractive index of glass. Refractive index of water is less than refractive index of glass. Right? That is the one conclusion what we have made. Now comes to what is the refractive index of free space. Now see here, this is also free space. What is there in free space? Air. What is the speed of light in air? 3 into 10 power 8 meter per second. What is the speed of light in vacuum? 3 into 10 power 8 meter per second. Then what is the speed of light in this free space? Since air is there, 3 into 10 power 8 meter per second. That's why n of free space, use the same formula. N is equal to C by V. N of free space is equal to this C. Here write the same C. Whereas here the speed of light in any medium. Here any medium means free space. So speed in free space. Speed in free space means that the free space is filled with air. So it is equal to 3 into 10 power 8. So C value is 3 into 10 power 8 meter per second. Speed of light in free space, because air is the medium, that's why it is also 3 into 10 power 8. Both get cancelled. That's why refractive index of air or vacuum or free space is equal to 1. So refractive index of air or free space or vacuum is equal to 1. Refractive index of glass is 1.5. Refractive index of water is 1.33. You can make the comparison. Which is least? Refractive index of free space is least. Compared to that, refractive index of water is least. Compared to that, refractive index of glass is okay. Now coming to the other way, refractive index of glass is greater than refractive index of water. It is still greater than refractive index of free space. Now why is that happening? You have come to know that is dependent on speed of light. That's it. What is the speed of light in first medium? What is the speed of the light in second medium? So let us see at the last. Okay, next. This refractive index has no unit. It has no unit. Unlike the other quantities like area, meter square, volume, meter cube. Right? Then the other various units like time in seconds. So certain physical quantities have unit. This refractive index is just a constant number. It has no unit. Why? Because you can see here speed of light, that is C, that speed is, the unit is meter per second. Denominator is also speed, that is also meter per second. Meter per second cancels, so you get only number. That's why refractive index has no unit, it is just a constant. Next, given two mediums, consider two mediums. One is rarer medium and denser medium. Rarer and denser medium. A medium with higher refractive index. Whichever medium is there, higher refractive index. Now compare. Compare to 1.5, 1.33 and 1. Which is having higher refractive index? Glass. So a medium with a higher refractive index is optically denser compared to the medium with lower refractive index. Which means given medium, a medium with a higher refractive index means it is optically denser, or it is called as denser medium, as compared to the medium with the lesser refractive index, which is called rarer medium. Now you compare to the glass and air, which is rarer medium. Air is the rarer medium. Why? Because refractive index is less. Water is the denser medium because refractive index is more. Compare glass and water. No, don't go for air. Compare glass and water, which is having more refractive index, glass. So glass is supposed to be optically rarer medium compared to the water. Understood? So that is the meaning of this. Next. Therefore, water and glass are optically denser compared to air. Now see here, this last note is there. N is equal to C by V. If N is equal to C by V, what is V is equal to? V is equal to C by N. Now see here, V is equal to C by N, very important. In the right hand side denominator you have refractive index. In the left hand side you have speed. What is the relationship? Both are inversely related. ಕನ್ನಡದಲ್ಲಿ ಏನಂತೀವಿ, ತೆಲುಗಿನಲ್ಲಿ ಹೇಳ್ತೀವಲ್ವಾ, ಯಕ್ವಾ ತಕ್ವಾ ಅಂದ್ರೆ ಏನು? ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಕಡೆ ಇರೋದು ಡಿನಾಮಿನೇಟರ್ ಜಾಸ್ತಿ ಆದ್ರೆ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ ಇರೋದು ಕಡಿಮೆ ಆಗುತ್ತೆ. ಮತ್ತೆ ಅಥವಾ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ ಇರೋದು ಕಡಿಮೆ ಆದ್ರೆ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಕ್ವಾಂಟಿಟಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಒಂದು ಜಾಸ್ತಿ ಒಂದು ಕಡಿಮೆ. ನಾವು ಸಿ ಹಿಯರ್, if the refractive index is more means speed is less. Now you can make the comparison here, okay? If the refractive index is less means speed is more. Now see here, which is having the lesser refractive index? Refractive index of air or free space or vacuum is less. That's why speed of light is more in air. 3 into 10 power 8 meter per second. Now see here, compare these three again. This water is having 1.33 as compared to air. That's why its speed still decreases. Now see, the refractive index of glass is 1.5, more denser as compared to air. That's why speed still decreases. So in given three mediums of glass, water and air, in which medium the speed of light is very less? It is very less in glass. Why? Because its refractive index is more. So more the refractive index, lesser the speed. Understood? So this is the relationship between refractive index, speed of light in air or vacuum, speed in any other medium. Then what is the relationship between refractive index and speed? When it is getting increased and when it is getting decreased. Remember, speed of light is inversely proportional to the refractive index because V is equal to C by N. This is speed of light in air or vacuum which remains constant. Okay? Thank you. Okay students, we were speaking about the refractive index. So what exactly is the refractive index? N is equal to C by V. It is defined as the ratio of speed of light in air or vacuum or free space to the speed of light in any medium. Now, on what factors this refractive index depends? So it majorly depends on two factors, okay? Refractive index depends on two major factors. One is nature of the material of the medium. What is the nature? What do you mean by nature of the material of the medium? This medium in free space is air. It depends on air. Then what about in water? You have water molecules, right? It depends on the molecules of water. Suppose in glass, it depends on the composition of the glass, how the glass is being made, that material, okay? The first is nature of the material of the medium. The second thing is color or wavelength of the light. So that is very important. It is also dependent on wavelength because in the white light you have different colors, right? We have Vibgay or violet, indigo, blue, green, yellow, orange and red. Different color is having different wavelength. So what is the color that is being sent from rarer to denser? Okay, so that wavelength, it also depends on color or wavelength of light. Okay, so these are the factors in which the refractive index depends upon. Now you have certain medium and its respective refractive indices. Now you can see here, for air you have 1.0003, for water 1.33, for glass 1.5. We have seen this. These three we have seen. Now you also have the other two examples which I have taken. The refractive index of kerosene is 1.44. Kerosene is also an optical medium. Now turpentine is also an optical medium which is having the refractive index of 1.47. Now this is about refractive index. Now going to the next concept, relative refractive index. Relative. What do you mean by the word relative when you hear that? Means we have our relatives, right? Means we are making that relationship. How? Like fathers, sisters, son. Okay, like that we make the relations, right? So why we keep on going through the relationship tree. Similarly here also, the relative refractive index means given any two mediums, okay, how we are able to relate to the other mediums, keeping in a constant or keeping the value of one particular medium which is known. ಯಾವ ಒಂದು ಮೀಡಿಯಂ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ನಮಗೆ ಗೊತ್ತಿದೆ ಅಥವಾ ಅದನ್ನ ನಾವು ರೆಫರೆನ್ಸ್ ಆಗಿ ಇಟ್ಕೊಂಡು ಬೇರೆ ಬೇರೆ ಮೀಡಿಯಂದು ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ನ ಕಂಡುಹಿಡಿಯೋದು ಅಥವಾ ಕಂಪೇರ್ ಮಾಡೋದು, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ರಿಲೇಟಿವ್ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್. Now, for this relative refractive index, there is in a specific format how we have to write. You have to write here, you have to write n. To the top left corner of the n, you are writing 1. To the bottom right corner of to the n, you are writing 2. How would you have to spell this, or how we have to say this? Refractive index of medium 2. Always you should say refractive index of first the bottom thing, the number medium 2 with respect to, make a comparison with respect to medium 1. Refractive index of medium 2 with respect to medium 1 is this is how we have to read this, okay? Refractive index of medium 2 with respect to medium 1. Now, refractive index of medium 2, refractive index of medium 2 with respect to medium 1. Okay, how we can call this refractive index of medium 2 with respect to medium 1 as? You can even refer to the n is equal to C by V formula, right? Now, refractive index of medium 2 with respect to medium 1, which is equal to n2 by n1. Refractive index of medium 2 with respect to refractive index of medium 1. You know the relationship between refractive index, speed of light in air and speed of light in any medium. N is equal to C by V. So how you write this? Refractive index of medium 2 with respect to medium 1. Now C remains constant. C remains constant. For the numerator I am writing. This is numerator, this is denominator. For the numerator N2 I have written C by V2. C by V2 whole divided by, for N1 also C remains constant. I have told you C will remain constant. C by V1. This is for denominator. So this is for numerator and this is for denominator. Now, refractive index of medium 2 with respect to medium 1 is equal to, write the numerator as it is, C by V2. This division sign will go to multiplication sign. This will go to the reciprocal. Take the reciprocal of the denominator into V1 by C. Now CC gets cancelled. Refractive index of medium 2 with respect to medium 1 is equal to V1 by V2. Now, how to write this? Refractive index of medium 2 with respect to medium 1 is equal to speed of light in medium 1, ratio of speed of light in medium 1 to the ratio of speed of light in medium 2. Now replace medium 1. Now replace medium 1 with respect to air and medium 2 with respect to water. Always take the example of air, water and glass so that the concept is understood. Now you can see here, let me replace this 1 by air. I will write here as air and here as water. Okay, W. Now how to read this? Refractive index of water with respect to air is equal to speed of light in air to the speed of light in water. Okay, understood? Now, what we have written? So, refractive index of medium 2 with respect to medium is equal to speed of light in air to the speed of light in water, or speed of light in medium 1 to the speed of light in medium 2. Now, just carefully observe here, in this relative refractive index only, I will make certain modification. I will just interchange the mediums. Now let me see. Now you have a refractive index of medium 2 with respect to medium 1. Now I will write here medium 1. Now I will write here medium 2. Again, follow the same procedure. How you have to follow? Refractive index of medium 1 with respect to medium 2 is equal to, so spell it, refractive index of medium 1 with respect to refractive index of medium 2. Again, express this refractive index in terms of velocity. of light, that ratio formula. So what you will get is equal to C by V1 whole divided by C by V2, right? Or refractive index of medium 1 with respect to medium 2 is equal to, now this is numerator and this is denominator. So you will get C by V1, this division sign which changes to multiplication sign, take the reciprocal, V2 by C, C gets cancelled, you will get refractive index of medium 1 with respect to medium 2 is equal to V2 by V1. Now you can have the comparison. Call this as equation 1, call this as equation 2. Make a comparison here. Now see here, refractive index of medium 2 with respect to medium 1 is equal to speed of light in medium 1, ratio of speed of light in medium 1 to the speed of light in medium 2. Refractive index of medium 1 with respect to medium 2 is equal to speed of light in medium 2 to the speed of light in medium 1. Now multiply 1 and 2. What you have to do? Multiply equation 1 and equation 2. What do you get? Refractive index of medium 2 with respect to medium 1 into refractive index of medium 1 with respect to medium 2 is equal to V1 by V2 into V2 by V1. So we'll get V2 cancels, V1 gets cancelled. I just proceed here. Now what you get? Refractive index of medium 2 with respect to medium 1 into refractive index of medium 1 with respect to medium 2 is equal to 1, or refractive index of medium 2 with respect to medium is equal to 1 by refractive index of medium 1 with respect to medium 2. Means both are reciprocal to each other, right? Both are reciprocal. For this is the reciprocal. For this, 1 by refractive index of medium 2 with respect to medium 1 is the reciprocal. Both are reciprocals to each other. Understood? Okay students, as I was explaining the relative refractive index, we have arrived at the conclusion that refractive index of medium 2 with respect to medium 1 is the reciprocal of refractive index of medium 1 with respect to medium 2. Now to explain this, I have considered three mediums: air, water and glass. Let Na represents refractive index of air, Nw represents refractive index of water, Ng represents refractive index of glass. Now I will first make a comparison with air and glass. Refractive index of glass with respect to air means refractive index of second medium with respect to first medium is, here we are writing only for glass because refractive index of this we are making a relative, means considering this as constant. So that is equal to 3 by 2, which means refractive index of glass we are finding out in relation to the refractive index of air. Okay, now that is 3 by 2. Similarly, from this formula, since they are reciprocal, refractive index of air, now here air has come with respect to glass is what? Reciprocal, 1 by 3 by 2. You will get what? 2 will go to the numerator, 3 is in the denominator, 2 by 3. Now multiply these two. What you will get? Refractive index of glass with respect to air into refractive index of air with respect to glass is equal to 3 by 2 into 2 by 3. 2, 3 cancels, you will get 1. Same you have got. That is, if you cross multiply these two, you will get 1. Or else I can write in this form, refractive index of glass with respect to air is equal to 1 by refractive index of air with respect to glass. So I have made a comparison for air and glass. Now I will next I will do a comparison with air and water. Okay, now you can see here refractive index of water with respect to air is what? 4 by 3. Here we are doing it for only water. Why? Because we are finding out the refractive index of water in relationship with the known value of refractive index of air. So refractive index of water with respect to air is equal to 4 by 3. Now therefore, hence refractive index of air with respect to water is equal to the reciprocal, that is 3 by 4 you will get. Now multiply these two. Refractive index of water with respect to air into refractive index of air with respect to water is equal to 4 by 3 into 3 by 4. Both get cancelled and it is equal to 1. Which means to say that if you multiply these two, you will get 1. Again, we have arrived at the same conclusion. Or else we can say refractive index of water with respect to air is equal to reciprocal of refractive index of air with respect to water. Now, in these two relative refractive indices, what we have found out, just observe that we have made common as air. Means the light is entering through the first medium with the air. And we are finding out the relative refractive index only for water. Now, our intention is to find out between these two, water and glass. Now, first air will come, next water, next glass. Now, we have to find out water and glass. Again, in order to find out the relative refractive index between water and glass, you have to make a comparison or you have to relate these two to air only. Now you can see here. Refractive index of glass with respect to water. Okay. Now we don't know, assume that we don't know both the refractive indexes of water and glass, but we know the refractive index of air. Ultimately, you have to make a relation or you have to take a relative refractive index of air in order to find out or in order to establish a relationship between refractive index of glass with respect to water. So see here, this can be written as refractive index of glass with respect to air. Now see here, divided by refractive index of water with respect to air. This we have found out. Okay. After this, what is this refractive index of glass with respect to air is nothing but refractive index of glass by refractive index of air, because refractive index of the second medium divided by refractive index of the first medium divided by, seeing the denominator, refractive index of water with respect to air is what? Refractive index of second medium, that is water, divided by refractive index of the first medium, that is air. Now, this Na will cancel, you will get Ng by Nw. So, refractive index of glass with respect to water is refractive index of glass by refractive index of water, just we have found out. That is N1 by N2. Okay. Sorry, N2 by N1. NGW, that is refractive index of glass with respect to water, that is refractive index of medium 2 with respect to medium 1 is equal to refractive index of medium 2 by refractive index of medium 1. Now, you know what is the value of refractive index of glass. It is given in the ratio, that is 3 by 2. 3 by 2 means 1.5 only. So let us take in the ratio, that is 3 by 2. Refractive index of water is given, you know that it is given in the ratio 4 by 3. Now take numerator 3 by 2 into, take the reciprocal of 4 by 3, you get 3 by 4. Now 3 3s are 9, 2 4s are 8. Now this is the value for this relative refractive index, that is refractive index of glass with respect to water is 9 by 8. How we have arrived at this 9 by 8? By taking the middle factor. What is that middle factor? The refractive index of air in between water and glass. Without taking the refractive index or without considering the refractive index of air, you cannot get the refractive index, or you cannot get the relative refractive index between water and glass. See here, wherever we are taking air into consideration. Thereby we are finding out the relative refractive index between glass and water. Here glass is medium 2, water is medium 1. We are taking into the other medium, that is air, into this mathematical relationship. Understood? Thank you. Okay students, we were doing the refraction. Now, what is the cause of refraction? Why this refraction is happening? It is only because of one basic reason, because of the change in the speed of light. That is, when the light is going from one medium to another medium, there is change in its speed. That is the main reason why there is the refraction. Why? Because you know the speed of light in air, you know the speed of light in water, you know the speed of light in glass. All these are varying, right? And again, that is dependent on the various other factors, you know that. Because that is refraction depends on, that is the refractive index depends on. So the basic reason for the refraction is change in the speed of light. That is when the light is going from one medium to another medium. Now moving to the next concept, that is how we have learned the law of reflection. We studied two laws of reflection, right? Similarly here also we have laws of refraction of light, where we study three laws. Okay, let us study now the first law. What is law of refraction? Whenever light goes from one medium to another, frequency of light does not change, but velocity and wavelength of the light changes. Which means every the source, the light in general, you can say the white light, okay, its frequency will remain constant. Okay, there is one more formula which tells that the frequency remains constant, whereas the velocity and the wavelength, okay, changes. So here the frequency of the light will remain constant, which means when the light is entering, okay, when the light is entering rarer medium, that is when the light is entering the rarer medium, that is air, and when it is entering the glass or water also, the wavelength or the velocity of the light will vary, whereas the frequency of the light in air, the frequency of the same light when it comes to water, or the frequency of the light when it goes to glass, the frequency remains constant. Only the varying parameters are wavelength and the speed of the light. Okay, the velocity means speed, and the wavelength of the light changes. Now, the incident ray, refracted ray, and the normal to the interface of two media. You know the interface of two media, that is medium 1 and medium 2. Which are the two rays or the three rays that will come? You will have the normal and you have the incident ray to the normal. Then in the medium 2 there is refracted ray, right? That refracted ray is always, the angle of refraction is less. Why? Because the refracted ray is bending towards the normal, whereas the incident ray or the angle of incidence is more. So all these three, normal, incident ray and the refracted ray, at the interface of two media, at the point of incidence, that O is there, right? At the point of incidence, they all lie in the same plane. Just like law of reflection, first law, incident ray, reflected ray, and the normal at the point of incidence all lie in the same plane. Similarly, this also all lie in the same plane. If I am writing in the vertical plane, it lies on the vertical plane. If you are writing in the book, that is in the horizontal plane, it lies on the horizontal plane. That's it. Now, the third law, which is very, very important. Now, the product of refractive index and sine, you can see here, sine of the angle of incidence. Here, sine means not this signature sign. S-I-N-E. Sine means, in mathematics you will study a separate chapter called trigonometry, where you will have 6 trigonometric ratios: sine, cosine, tangent, cotangent, secant, cosecant. In that, the first trigonometric ratio, that is sine. Okay, so that sine of the angle means here what? You have the angle of incidence or angle of refraction. Okay, that sine of the angle of incidence here, incidence at a point in a medium is constant. Here they have mentioned the third law to be for one medium. That's why the product of, you can see here, this is the product of refractive index and sine of the angle of incidence remains constant. Means that value is a constant number, it will not change. Now, suppose if you have in refraction you require two mediums, right? This law states for one medium, but we are having only two mediums. Because one is rarer, one is denser, then only reflection will happen. How to write the same law for the two mediums? Now, suppose the first medium is there. Use the same formula for the first medium, that is rarer medium. N1 sin I1 is equal to N2 sin I2. I1, where 1 represents first medium, here 2 represents second medium. Means rarer and denser. You know that in the rarer medium, that I1 is nothing but what? I means angle of incidence. In the denser medium, that is medium 2, that I2 is nothing but what? R. R is nothing but angle of refraction. Now you write, in place of I1 you write I, in place of I2 you write R. So what you will get? N1 sine I is equal to N2 sine R. Now, N1, bring this to the numerator, N2 divided by N1 is equal to, here you have sine I divided by, this will come to denominator sine R. So, refractive index of second medium, the ratio of refractive index of second medium to first medium, that is nothing but what? Refractive index of the second medium with respect to first medium is equal to ratio of sine of angle of incidence to the sine of angle of refraction. I repeat, the ratio of, the refractive index of medium 2 with respect to medium 1 is equal to ratio of sine of angle of incidence to the sine of angle of refraction. This was given by the physicist or scientist Snell, S-N-E-L-L, Snell in 1621, and it is popularly called as in optics Snell's law. Very important. Okay. Snell's law is just like how Ohm's law is very important in electricity. In optics, Snell's law is very, very important. Okay. The two for refraction. So, refractive index of second medium with respect to first medium is ratio of sine of angle of incidence to the sine of angle of refraction is called as Snell's law. This is supposed to be the third law of refraction. So third law of refraction is popularly called as Snell's law. Okay? Thank you.